Alright, so the first question I want to talk about is the first question on the back of the example problems that are on the back of the periodic table information graphic organizer. So the first question is asking what period are each of the following elements in. So for all these questions, you're going to want to be looking at your periodic table. But if you look at the periodic table, you will locate helium, and helium is on that first row. Remember, the word period means rows on the periodic table. So since helium is on the first row, we would say it's in the first period, which is the same thing as the first energy level. So that would be the answer for that one. And rubidium, you look, it's all the way on the left. It is down on the fifth row if you count from the top down to rubidium. So that's the fifth energy level or the fifth period. So those are our answers for the first question. So moving to the second question, which group, another word for group is family, are the following elements? Okay. Groups and families, where we see these on the periodic table, are the columns, and only a few of these actually have specific names that we need to know. But sulfur, if you look, it's over on the right of the periodic table. It's located in the column that has 6 valence electrons, which is also known as group 6A. This does not have a name that we need to memorize, so group 6A is good enough for this question. And then calcium, if we look, it's in the second column, so that would be group 2A, but we have an actual name for that one. That column is our alkaline earth metals. So those are the answers for those, which each of these two problems so far has additional parts, but I just wanted to give you an example so you know how to figure out the answers. Okay, so sulfur, group 6A, which is also called group 16, and sulfur is a non-metal, so that means that it's to the right of the staircase. Calcium is a group 2A, which is also known as an alkaline earth metal. And that name should remind you that calcium is a metal, not a non-metal. Okay, then we move to question 3, and we're supposed to organize the elements in terms of their atomic radius, so how big the atoms are. And if we give it a 1, that would be the smallest. If we give it a 4, that would be the biggest. So if you recall, the atomic radius increases or gets bigger as you move to the bottom left of the periodic table. So towards the corner where francium is located. And so the closest element to francium would be cesium here. So cesium is going to have to be the biggest out of all of these. So we would give cesium a 4. Okay. Then let's see, lead. Lead is close to the bottom of the periodic table, but it's a little further to the right. But it's definitely a really big atom. It's got a mass of 200. So I would say this is probably going to be the second biggest, so I would give it a 3. Hydrogen is the top left element, and it's also the lightest element on the periodic table. So as far as being further left, we would think maybe it's a little bit bigger, but it's only got 1 electron. It's a very tiny atom. So I would say this is going to be our smallest. So I would give this a 1. And then calcium is a little bit further down, but it's still on the left side of the periodic table. So this is obviously going to be 2 because that's the last one we have. It's kind of a medium-sized atom because it's only got a mass of 40, but it is on the left of its entire row. So it's going to be bigger than the stuff that's to the right of it, but smaller than the stuff that's on the next row down. Okay. Then we're going to move to our last question. The most reactive metals are in which group, and the most reactive nonmetals are in which group? Okay, so remember, most reactive metals, these are ones that are easier to get rid of its valence electrons, and that's because they have fewer valence electrons and bigger atomic radius. So these are going to be the ones that are in the far left column, since it's looking for an entire group or family. So the far left column we would call the alkali metals. So that's the answer for this one. The alkali metals are the most reactive metals. The most reactive nonmetals are the ones that it's easier for them to gain an electron. So these are the ones that have 7 valence electrons. They're really close to getting to 8. and they have a very small valence shell. So basically just the 7 valence electrons will clue us into the fact that the group must be the halogens. So those are the answers for those 2 questions. Okay. Now, these questions are question number 12, related to that concept of figuring out which elements would react with each other. And so just a hint, we're going to learn about why this is later, but usually metals will react with non-metals, where we can actually observe some sort of chemical reaction. And this is because they have opposite charges. So we have to figure out in the pairs whether the elements are metals and non-metals. Rubidium is to the left. Excuse me. It's to the left on the periodic table, so that would make it a metal. And bromine is to the right on the periodic table, to the right of the staircase, so that would make it a non-metal. So we have metal and non-metal. These are very likely to react. Now let's think about what their charges are. Rubidium has a +1 charge, and bromine has a -1 charge. So they both have opposite charges. They're very likely to bond with one another, so they're very likely to react. All right, then we get to argon and aluminum. Argon is right here in this column. These elements don't form ions. They're very stable. So that means that argon is not reactive at all. Aluminum, however, can form an ion, but since argon is not reactive and these don't have opposite charges, it's not really going to happen. Then we have sulfur and beryllium. Beryllium is here, +2 charge. Sulfur is here, -2 charge. These have opposite charges. Beryllium is a metal, sulfur is a non-metal, so they're very likely to react. We get to iron and magnesium. Iron is in the middle. It's not showing up on here, but it is Fe. It's a transition metal, so that means it's a metal. And magnesium is also a metal. It's +2. So iron would have a positive charge. Magnesium has a positive charge. They're not likely to bond. Nitrogen and oxygen. They're both right here. They both form negative ions because they're both non-metals. So they're not very likely to react. We will learn later about what non-metals do to form compounds, but for our purposes now, this is not going to happen. And then we get to zinc and sulfur. Zinc is a metal, sulfur is a non-metal. So zinc is more likely to form a positive ion, sulfur is more likely to form a negative ion, so the reaction between them is possible. Okay, so I've highlighted these ones. Rubidium +1, bromine -1, they're going to bond, and they have opposite equal charges, so it's really likely to be able to happen. Sulfur and beryllium, they have opposite charges, they're very likely to bond. And zinc and sulfur, they have opposite charges, they're very likely to bond. Now, next question. Let's predict which reaction will be the most vigorous or the most violent. So which one's going to happen the fastest and the strongest, and which one will be the calmest, meaning the slowest and the most gentle. Okay, so to think about that, we need to look at how reactive each element is. Rubidium, is it a reactive metal? Well, our reactive metals are closer to the bottom left. So rubidium's right here. I would say it's pretty reactive compared to all the other metals to the right of it and above it. Bromine is right here, so it's a fairly reactive non-metal as well. So that's why I said that this would be the most vigorous reaction out of all of them, or the most violent. Sulfur and beryllium. Beryllium's up here. It's not that reactive of a metal because it's pretty far from the bottom. It's a small atom. It's holding on to its electrons fairly tight. But sulfur's pretty reactive, so this is probably somewhere in the middle. And since we know sulfur's pretty reactive in the next one, but zinc is a transition metal. It's probably less likely to react than beryllium. At least that would be my prediction based on the fact that it's so far to the right on the periodic table. So I would say that this looks like it would probably be the calmest reaction out of all of them, and this would be in the middle. Alright, so that's the end of our discussion for this topic. I would hope that you can do similar problems to these, so I would like for you to try to complete the other questions on the back of this so you're ready for your notes quiz on Monday. Some of this is explaining why the trends happen on the periodic table, so you'll want to review your notes from this past week that we took in class, and you feel free to use other information on the internet to help you to answer these questions before we get to our notes quiz on Monday. Thank you.